This is Geometry Lesson 6.3, Arcs and Angles. So, we have a few conjectures. I'm going to draw out what those rules look like on the circles next to them. The first one says the measure of an angle inscribed in a circle is blank. So, on the previous lesson, we looked at central angles, and we knew that whatever measure the central angle was, let's give that x, this arc would be the exact same measure. That's a central angle. Inscribed angles are angles drawn all the way in the circle, going to the edge of the circle, not stopping at the center. Now the relationship here is every single inscribed angle will be exactly half whatever the central angle or the arc measures. So I know that if my arc on the outside here is 100 degrees, I would end up with 50 degrees on the inside. And I can go the reverse way as well. I know that this is maybe 40 degrees, then these would both each have to be 80 degrees. So cut in half to go into the circle, double it to go out of the circle. So that angle could overlap the other one as well. So as long as the endpoints here match, let's say I drew another angle over here, but the endpoints match, it would still be the same measure. So whatever this one is, this one would be the exact same, as long as those endpoints match up. So inscribed angles that intercept the same arc are congruent. My next rule reads, cyclic quadrilaterals. The opposite angles of a cyclic quadrilateral are a blank. So a cyclic quadrilateral is a four-sided shape drawn into a circle. I went too many. 1, 2, 3, 4. So I have any four-sided shape drawn inside a circle. The opposite angles, so that would be this angle and this angle, will always add up to 180 degrees. That would be true of these angles as well, but any two angles across from each other need to add up to 180. Supplementary is our official word for that, but in case we forget what that means, add to 180. And I think we have two more down here. The first one says angles inscribed in a semicircle. So I have a semicircle right here on the top half of this circle. And if I wanted to inscribe an angle on that, that means I would use the endpoints A and B and draw an angle all the way to the edge of the circle. So I have an angle inscribed in half of a circle. The measure of that angle will be the same regardless of where you put that angle. If I had put that angle here, or if I'd put that angle here, anytime we inscribe an angle in a semicircle, every one of those measures exactly 90 degrees. And if you think about our first rule, if this full circle is 360 degrees, that means half of the circle here would be 180. And if you have an arc on the outside and you inscribe it, it'll be exactly half of that. And the bottom one says the arcs between parallel lines on a circle are blank. So I have a parallel line here and here. This one tells me that the piece of the arc here would be congruent to the arc right here. So I'm going to add some little congruent marks on those arcs right there. Between two lines, the arcs are congruent. Now, this lesson doesn't have any examples on it, and rather than try to take up more paper, because there are quite a few of these, I'm just going to do one of the exercises, and I think I'm going to do letter number 3, letter C. So I see an inscribed angle here, and to bring an inscribed angle to the arc, we need to double it. So 95, double that, we get 190. That means that this arc starting here and ending here, that's the endpoints of the angle, is 190 degrees. My goal is to figure out how big this arc is. So if that whole one I drew in red is 190, this piece here in green is 120. I can do 190 minus 120 to get me the arc of 70. If you keep in mind that inscribed angles need to double to get out of the circle, that is the main idea of this lesson. Trying to make 180 where it's supposed to, try to make 360 where it's supposed to. Good luck on these, and let me know if you have any questions.